this is Ava, and I'm going to present my research on development and evaluation of sodium butyrate conjugated curcumin for drug delivery in MDA-MB231 breast cancer cells. Cancer refers to the development of abnormal cells that divide uncontrollably and can damage healthy body tissues. One type of cancer is triple-negative breast cancer, or TNBC cancer, which is an aggressive type of breast cancer lacking estrogen, progesterone, and human epidermal growth factor receptors, also known as HER2, making it unresponsive to hormonal or HER2 targeted therapies. MDA-MB231 cells are a model of TNBC cancer cells known for their resistance to common treatments. While chemotherapy and surgery remains effective, they both lack cancer cell selectivity and will lead to severe side effects. Curcumin is the main active compound in turmeric and has anti-cancer and therapeutic potential by inducing apoptosis through upregulation of pro-apoptotic genes, which themselves will lead to upregulation of pro-apoptotic proteins and decreasing cell viability. However, curcumin's therapeutic potential is limited by its poor solubility, low stability, and its rapid metabolism, which all will result in reduced bioavailability of this compound. Sodium butyrate is a short-chain fatty acid and histone deacetylase inhibitor and has demonstrated pro-apoptotic effects in various cancer models. Sodium butyrate is water-soluble and it has a very high cellular uptake, which makes it a promising candidate for conjugation with curcumin. This study explores the conjugation of sodium butyrate and curcumin using cis-ecnotic anhydride, referred to as Ca, which is a pH-sensitive linker. This linker can conjugate curcumin to sodium butyrate with forming an ester bond between these two compounds. This study hypothesized that sodium butyrate Ca curcumin conjugate will improve cellular uptake and reduce cell viability of MDA-MB231 cells more effectively than curcumin alone. First, the conjugate was synthesized and its conformation was validated through ferric hydroxamate assay. Then the cellular uptake of curcumin and conjugate was measured and statistically compared to each other. And finally, the cytotoxicity of curcumin, sodium butyrate, and conjugate treated cells were measured using MTT assay and statistically compared within each treatment. Ferric hydroxamate assay confirmed and validated the formation of the conjugate, indicated by the red and dark brown color in the test tube containing the conjugate, which showed the presence of ester bond in the conjugate. Cellular uptake results showed that the mean cell fluorescence by 15 minutes, 3 hours, 17 hours after treatment was significantly different in the curcumin treated cells compared to the vehicle control. But at 23 hours, the curcumin mean cell fluorescence was not significantly different anymore compared to the vehicle control. This is while the conjugate was significantly different at all time points, including 15 minutes, 3 hours, 17 hours, and 23 hours after treatment. In addition, by 15 minutes after treatment, the conjugate was not significantly different compared to the curcumin-treated cells, while at 3 hours, 17 hours, and 23 hours after treatment, conjugate was significantly different compared to the curcumin-treated cells. MTT assay results showed the cell cytotoxicity of curcumin treatment, indicated by the significant decrease when the cells were treated with curcumin 50 micromolars. In sodium butyrate treated cells, however, the cell viability did not significantly change through the treatments, which was not unexpected due to the low concentrations of the treatment used in this study. However, interestingly, the cell viability of conjugated treated cells were significantly increased after treatment compared to the negative control, while the conjugate vehicle control had a significantly decrease in the percent cell viability. The significant decrease in the cell viability of the conjugate vehicle control was due to the DCC residue in the vehicle control, while the treatment concentrations of conjugate at 25 and 15 micromolar were possibly not high enough to kill cells, but they were high enough to increase the metabolic activity of the cells. These findings support the hypothesis that curcumin conjugation with sodium butyrate using CA linker improves curcumin's cellular uptake and stability. However, cell viability significantly increased in conjugate-treated cells, possibly due to the hermetic effect on the cells, indicating that the conjugation enhanced metabolic activity rather than induced cytotoxicity at low doses and needs further concentration optimizations.